So today we are discussing questions related to finding shortest distance and the line connecting shortest distance between two given lines. So let's get started. So the question number 1 says that obtain the coordinates of the point where the shortest distance line between the straight line this and this meets them. Also find the magnitude of shortest distance and the equation of shortest distance line between the straight lines mentioned above. So they have given me two lines. Let's say L1 is x minus 3 upon minus 1 equals to y minus 2 upon 2 equals to z minus 2 upon minus 1. And my line L2 is x minus 2 upon 2 equals to y plus 3 upon 3 equals to z plus 2 upon 2. So if this is my line L1, let's say, and this is my line L2. So, and let's say this is my shortest distance. So we are supposed to find coordinates of point this of A and B, where A is the intersecting point of the shortest distance line in L1 and B is intersecting point of shortest distance line in L2. And further we are supposed to find this distance AB, and also they have asked us to find the equation of this line AB. So they have given me equation of line L1 and L2. So let L1 be equals to A some constant and it be equals to B some constant. So I can find out any arbitrary point on line L1 and L2. So any arbitrary point on L1 will be A. So my A will be of form minus A plus 3, 2A plus 2 and minus A plus 2. And on L2 any arbitrary point will be of form 2B plus 2, 3B minus 3, 2B minus 2. So these are my arbitrary points on equation of line L1 and L2. So if AB is my shortest distance, if AB is shortest distance between L1 and L2, so AB must be perpendicular to L1 and L2. So using that, if I calculate direction ratios of line AB, then I can use the perpendicularity result and get some relation in between A and B, and then we can solve that to find out values of A and B. So my direction cosines of AB will be it will be 2B plus 2 minus A plus 3, 3B minus 3 minus 2A plus 2 and 2B minus 2 minus A plus 2. If I simplify it, I will get 2B plus A minus 1, 3B minus 2A minus 5, 2B plus A minus 4. So these are my direction cosines of line AB. So this equation of line with direction cosines proportional to this must be perpendicular to L1 and L2. So using perpendicularity result, I will get minus 1 into 2B plus A minus 1 plus 2 into 3B minus 2A minus 5, and then minus 1 into 2B plus A minus 4 equals to 0. I got using this relation L1 L2 plus M1 M2 plus N1 N2 equals to 0. So if I simplify this, I will get minus 2 plus 6 minus 2B plus minus 1 minus 4 minus 1A plus 1 minus 10 plus 4 equals to 0. On further simplifying it, I'll get 2B minus 6A equals to 5. And if I use the perpendicularity result with line L2, I will get 2 into 2b plus a minus 1 plus 3 into 3b minus 2a minus 5 plus 2 into 2b plus a minus 4 equals to 0. And if I simplify it, I'll get 4 plus 9 plus 4b plus 2 minus 6 plus 2a plus minus 2 minus 15 minus 8 equals to 0. On further simplifying it, I'll get 8 plus 9, 17b minus 2a, 15 plus 10, 25 equals to 25. So I have these two relations in a and b, and I can just solve these to get value of a and b. So my two relations are 2b minus 6a equals to 5 and 17b minus 2a equals to 25. So if I just multiply equation second with 3, so and then subtract equation second from equation first, I will get minus 15b equals to minus 75 plus 5 minus 70. So from here I got my b as 70 upon 15, which is equals to it's 17. I forgot to multiply 17 with 3. So it will be 17 3s are 51 minus 2 minus 49b equals to 70. So minus 70. So my b will be 70 upon 49, which is 10 by 7. So I got my b as 10 by 7. And likewise I can calculate value of a. So my a would be 2a equals to 6a equals to 2b minus 5, which is equals to 2 into 10 by 7 minus 5. So if I simplify it, 20 minus 35 by 7, which is minus 15 by 7, and on further simplifying it, I will get minus 15 by 7 into 6. So it is minus 5 by 14. So my a is minus 5 by 14. So now I can just substitute value of a and b, small a and small b, to get coordinates of point a and b. So my point a is minus a plus 3 comma 2a plus 2 minus a plus 2, 2a plus 2 and minus a plus 2. So if I just substitute value of small a, I will get 5 by 14 plus 3 comma 2 minus 10 by 14 comma 2 plus 5 by 14, which is equals to 47 by 14 comma 18 by 14 comma plus 5 33 by 14. Likewise I can calculate coordinates of b. So my point b was 2b plus 2 3b minus 3, 2b plus 2 3b minus 3 and 2b minus 2. So if I substitute value of b as 10 by 7, I'll get 20 by 7 plus 2 20 by 7 plus 2 comma 30 by 7 minus 3 and 20 by 7 minus 2. On further simplifying it, I will get 34 by 7 comma 21 9 by 7 comma 14 6 by 7. So I got my coordinates of a and b, where a and b are the points where the shortest distance line will intersect given lines. Further, we are supposed to calculate distance AB. So my distance AB, I can calculate it using distance formula since I have coordinates of both A and B. So my shortest distance will be 47 by 14 minus, I can write 34 by 7 as 68 by 14 square plus 18 by 14 minus 18 by 14 square plus 33 by 14 minus 12 by 14 square. So if I simplify it, I'll get 47 minus 21 by 14 square. This one will be 0 square plus 33 minus 12 minus 21, again 21 by 14 square. 3 minus 2 1, 3 minus 1 2, yeah 20. So if I simplify it, I'll get 21 by 14 under root 2, which is 3 root 2 by 2. This is my distance AB. Also they have asked me to find the equation of line AB. So equation of shortest distance line AB will be x minus 34 by 7 upon 47 by 14 minus 21 by 14 equals to y minus 9 by 7 upon 18 by 14 minus 9, it is 0, and z minus 6 by 7 upon 33 by 14 minus 6 by 14, which is 21 by 14. If I further simplify it, I will get x minus 34 by 7 upon minus 1 equals to y minus 9 by 7 upon 0 equals to z minus 6 by 7 upon 1. So this is the equation of shortest distance line. Move on to question number 2. So question number 2 is almost similar to the question number 1. So they have given us two lines which are x minus 3 by 3 equals to y minus 8 by minus 1 equals to z minus 3 by 1. So if I equate it with A, then I can find any arbitrary point on line L1. Let's say let name it as P. So any arbitrary point on line L1 will be 3A plus 3 minus A plus 8 and A plus 3. Likewise, I can find any arbitrary point on line 2. So my line L2 is x plus 3 by minus 3, y plus 7 by 2 and z minus 6 by 4. If I equate with B, then if Q is any arbitrary point on line L2, then I can find that, and that will be of form minus 3B minus 3, 2B minus 7, 4B plus 6. Since I have point P and Q that are any arbitrary point on given line, so I can easily find out direction cosines of line PQ. So direction cosines of line PQ will be 3A plus 3B plus 6 minus A minus 2B plus 15, A minus 4B minus 3. Now any line with direction cosines proportional to the direction cosines of PQ will be perpendicular to the line L1 and L2. So using the result of perpendicularity, we can calculate a relation in between A and B. So using that, I'll get 3 into 3A plus 3B plus 6 minus A minus 2B plus 15 plus A minus 4B minus 3 equals to 0. So if I solve this, I'll get 9 plus 1 into A plus 9 plus 2 minus 4 into B plus 18 minus 15 minus 3 equals to 0. So if I simplify it, I'll get 11A plus 7B equals to 0. Let us name it as star 1. And using perpendicularity result with line L2, I'll get minus 3 into 3A plus 3B plus 6 plus 2 into minus A minus 2B plus 15 plus 4 into a minus 4b minus 3 equals to 0. So if I simplify it, I'll get minus 9 minus 2 plus 4 into a plus minus 9 minus 4 minus 16 into b plus minus 18 plus 30 minus 12 equals to 0. So if I simplify this equation, I will get minus 7a minus 16 for 20 minus 29b equals to 0. Now from star 1 and star 2, I can find out that a and b are equivalent to 0. You can solve this and you'll arrive at a result where a and b are equals to 0 using star 1 and star 2. A equals to b equals to 0. So since I know value of a and b, I can easily get coordinates of p and q. So my p coordinate will be 3, 8, 3, 3, 8, 3, and my q coordinate will be minus 3, minus 7, 6, minus 3, minus 7, 6. So since I have coordinates of p and q, so using distance formula, distance pq will be 3 plus 3 square plus 8 plus 7 square plus minus 3 square. So if I simplify it, 6 square 36 plus 15 square 225 plus 3 square 9, and 36 plus 9 45, and 45 plus 25 270. So this is under root 270, and I can write it as 9 into 30, which is equivalent to 3 under root 30. And this is, we are supposed to prove that distance between perpendicular line joining L1 and L2 is 3 root 30. And further we are supposed to find the shortest distance line between L1 and L2. So shortest distance line will be x minus 3 upon 6 equals to y minus 8 upon 15 equals to z minus 3 upon 3 minus 6 minus 3. I can further simplify it to get 2 y minus 8 by 5 equals to z minus 3 by minus 1. So this is the shortest distance line between L1 and L2. So let's move. So the next question is, we are supposed to find the shortest distance between the lines a1x plus b1y plus c1z plus d1 and a2x plus b2y plus c2z plus d2. So this is our line, and we are supposed to find the shortest distance between this line and the z-axis. So they have given us basically two equation of planes, and the line of intersection of these planes will be the line, and we're supposed to find the shortest distance between that line and the z-axis. So they have given us equation of lines as a1x plus b1y plus c1z plus d1 equals to 0, and a2x plus b2y plus c2z plus d2 equals to 0. So equation of plane via given lines will be a1x plus b1y plus c1z plus d1 plus lambda into a2x plus b2y plus c2z plus d2 equals to 0. So if I simplify it, I'll get a1 plus lambda a2x plus b1 plus lambda b2y plus c1 plus lambda c2z plus d1 plus lambda d2 equals to 0. And I know that shortest distance line between the given shortest distance line between the given line and z-axis will be perpendicular to that line and z-axis as well. So we have direction cosines of z-axis as 0, 0, 1. So we know that the intersection line will be lying in both these planes. So intersection line must be perpendicular to the normal of these given planes. So what I am saying is, line of intersection must be perpendicular to normal to given planes. So and shortest distance line is perpendicular to line of intersection and z-axis. So using both these results, I can say that my normal to this plane must be perpendicular to z-axis. So using that result, I can say that a1 plus lambda a2 into 0 plus b1 plus lambda b2 into 0 plus c1 plus lambda c2 into 1 equals to 0. So if I simplify it, I'll get my lambda as minus c1 by c2. So using this lambda in the above equation of plane, I'll get my equation as a1 minus c1 a2 by c2 x plus b1 minus c1 b2 by c2 y plus c1 minus c1 c2 by c2 z plus d1 minus c1 d2 by c2 equals to 0. So if I simplify it, I'll get my equation as a1 c2 minus c1 a2 into x plus b1 c2 minus c1 b2 into y plus d1 c2 minus c1 d2 equals to 0. Now any point on z-axis will be of form 0, 0, let's say alpha. I am considering alpha because I am taking any arbitrary point on z-axis. Then using formula for shortest distance between a line, z-axis is basically a line and a plane. Using a formula of shortest distance between a line and plane, my shortest distance in between them will be a1 c2 minus c1 a2 into 0 plus b1 c2 minus c1 b2 into 0 plus d1 c2 minus c1 d2 divided by underscore a1 c2 minus c1 a2 square plus b1 c2 minus c1 b2 square. So if I simplify it, I'll get my distance as d1 c2 minus c1 d2 upon a1 c2 minus c1 a2 square plus b1 c2 minus c1 b2 square. So this is my shortest distance between given line and z-axis. That's all we are supposed to find. So now let's see next question. So in this question they have given us two equations and we are supposed to find the shortest distance and value of small m. So my equation of line L1 is x minus 1 by 2 equals to y minus 2 by 4 equals to z minus 3, and my line L2 is y minus mx equals to z equals to 0. So let us assume that let L dash, M dash and N dash be direction cosines of shortest distance line. So shortest distance line will be perpendicular to both L1 and L2. Let me simplify my equation too. So on simplifying, I'll get x equals to y by m equals to z minus 0 by 0. So using perpendicularity result, I'll get 2l dash plus 4m dash plus n dash equals to 0 and l dash plus m dash plus 0 n dash equals to 0. So I can solve it for l dash, m dash and n dash. So using cross multiplication, we'll get minus m upon m dash minus m dash to minus 1 equals to n dash upon 2m minus 4. 2m minus 4. So my direction cosines of shortest distance line will be minus m dash 1, 2m minus 4, or I can write it as minus m upon m square plus 1 plus 2m minus 4 square, comma 1 upon under root m square plus 1 plus 2m minus 4 square, comma 2m minus 4 upon under root m square plus 1 plus 2m minus 4 square. So these are my direction cosines of shortest distance line. So we are supposed to find the shortest distance. So shortest distance will be, so basically we have two arbitrary points on equation on line L1 and L2. So my line L1 is passing via 1, 2, 3 and L2 is passing via 0, 0, 0. So my shortest distance will be basically the projection of these two line, projection of line joining L1, L2 on the line with direction cosines this. So my shortest distance will be, if I calculate direction cosines of these two, I'll get direction cosines of, let me name it as A dash and B dash. So direction cosines of A dash, B dash will be 1, 2, 3. So my shortest distance will be, using projection formula, I'll get my shortest distance as minus m plus 2 into 1 plus 3 into 2m minus 4 and all these normalizing terms in denominator, that is m square plus 1 plus 2m minus 4 square. So if I simplify it, I'll get 5m minus 2 minus 12 minus 10 divided by m square plus 1 plus 2m minus 4 equals to 0. So this is my shortest distance. And further, we are supposed to find value of small m. What if two lines intersect? So if two lines intersect, then shortest distance must be 0. So we can just equate it with 2. Shortest distance equals to 0 if two lines intersect. So from here I got my m equals to 2. So for small m equals to 2, these two lines will intersect. So that's all we're supposed to prove in this question. So the next question is, find the magnitude and equation of line of shortest distance between the given lines. So let me name it as L1 and this one as L2. So we can find out any arbitrary point lying on L1 and L2. So any arbitrary point on line L1 and L2 will be, let on L1 it be P, so it will be 3a plus 8 minus 16a minus 9 and 7a plus 10. And arbitrary point on L2 will be 3b plus 15, 8b plus 29 minus 5b plus 5. Now using this I can find direction cosines of PQ. So direction cosines of PQ will be, it will be 3a minus 3b minus 7 and minus 16a minus 8b minus 9 minus 29, that will be minus 38, and 7a plus 5b plus 5. So shortest distance line has direction cosines perpendicular to these, and we know that shortest distance line is perpendicular to both L1 and L2. So using result on perpendicularity of two lines, we'll get 3 into 3a minus 3b minus 7 minus 16 into minus 16. I guess I forgot to write a here. Minus 16a minus 8b minus 38 plus 7 into 7a plus 5b plus 5 equals to 0. And if I simplify this, I'll get 9 plus 256 plus 49a plus minus 9 plus 16 into 8, 6 8 128b plus 35. And this is coefficient of b, and minus 21 minus 16 into 38 plus 7 5s are 35 equals to 0. So if I further simplify it, I'll get 56 60 65 200 300 314a plus 120 150 163 minus 9 154b plus, if I simplify it, I'll get, this one is plus, so I'll get 622 equals to 0. Likewise, I can use perpendicularity condition with line L2. So using that, I'll get 3 into 3a minus 3b minus 7 plus 8 into minus 16a minus 8b minus 38 plus minus 5 into 7a plus 5b plus 5 equals to 0. If I simplify it, I'll get 9 minus 128 minus 35a plus minus 9 minus 64 minus 25b plus minus 21 minus 38 into 8 304 minus 25 equals to 0. So if I simplify it, I'll get minus 154a minus 98b minus 350 equals to 0. So I can further simplify this. If I divide it by 2, minus 2, I'll get 77a plus 49b plus 175 equals to 0. I can simplify my above equation as well. So here I'll get 157a plus 77b plus 311 equals to 0. So if I solve these two equations, I'll get 157a plus 77b plus 311 equals to 0. So if I multiply it with 11 and I multiply it with 7 and then subtract it, I'll get 77 into 11 minus 157 into 7a. These two terms will balance out, plus 175 into 11 minus 7 into 311 equals to 0. So here I'll get minus 252a plus 175 into 11 minus 7 into 311, which is again minus 252 equals to 0. So I got my a as minus 1. and I can just substitute in the above equation to get value of b. So minus 77 plus 49b plus 175 equals to 0. So I got 49b plus 177 minus 77, 98 equals to 0. So my b is minus 2. So I got value of both a and b. So using this I can find my point P and Q. So my point P will be 8 minus 3, 16 minus 9, 8 minus 3, 5, 16 minus 9, 7, and 10 minus 7, 3. Likewise my point Q will be 15 minus 6, 9, 29 minus 16, 13, and 5 plus 10, 15. So my P is 9, 13, 15. So I can easily find shortest distance. So my shortest distance is PQ, which is basically, I'm just using distance formula, 9 minus 5, 4, 16, plus 39 minus 7, 6, 6 square 36, plus 15 minus 3, 12, and 12 square is 144. This is equals to 150, 160, 196 under root 196, which is equals to 14 square. Also, are we supposed to, we are supposed to find the magnitude and the equation of line. So since I have both the points, so equation of line via P and Q will be x minus 5 upon 9 minus 5, 4, y minus 7 upon 13 minus 7, 6, and z minus 3 upon 15 minus 3, 12. I can further divide it by 2, so I'll get x minus 5 by 2, y minus 7 by 3 equals to z minus 3 by 6. So this will be my required equation of line. So let's move on to next question. So the next question says that if 2C is the shortest distance between the lines this and this, then show that. We're supposed to prove this relation. So they have given us two lines. So my line L1 is x minus L by L equals to y minus 0 by 0 equals to z by n, and my line L2 is x equals to 0 comma y by m plus z by n equals to 1. Okay, so equation of any plane, I can find equation of any plane passing via. So here we are not supposed to find the shortest distance, we are just supposed to prove a relation if 2C is my shortest distance. So I'll consider a plane passing via line L2. So equation of plane passing via L2 will be of form y by m plus z by n minus 1 plus lambda x equals to 0. So if I simplify it, I'll get lambda into x plus y by m plus z by n equals to 1. Let us name it as maybe 1. So it is given to us that, so this is the equation of plane passing via line L2. So if this plane is parallel to my line L1, so this plane will be parallel to line L1 because my direction cosine, so because my normal to this plane will be perpendicular to the above line, because that will be the shortest distance between the two lines. So using that logic, using perpendicularity logic, I'll get lambda into L plus 0 into 1 by m plus n into 1 by n equals to 0. So from here I got my lambda as minus 1 by L. I got this, I use that, and if this is my, let's say, line L1, and let's say this is my line L2. So I have assumed a plane which is passing via line L2. So my shortest distance line will be basically perpendicular to both line L1 and line L2. So if this is my shortest distance line and it is perpendicular to line L2, then direction cosine of this shortest distance line and normal to this plane will be parallel, and using that result, in this logic I got my equation of plane. So my equation of plane will be, it will be minus x by L plus y by m plus z by n comma 1 equals to 0. Now I am supposed to find the shortest distance between this line L1 and line L2, and I know that line L1 is passing via L comma 0 comma 0. So my 2c, which is given to me as shortest distance, will be equals to minus L upon L plus 0 upon m plus 0 upon n minus 1 divided by 1 by L square plus 1 by m square plus 1 by n square. So if I simplify it, so to simplify it I can take square of both sides. So I'll get 4c square equals to 4 upon 1 by L square plus 1 by m square plus 1 by n square, which is equals to 1 by L square plus 1 by m square plus 1 by n square equals to 1 by c square. This is the relation we are supposed to prove. Yeah, I think this is the last question. So thank you for watching.